All right, welcome back. So we're gonna try example number 5. In this example, we're gonna use U-Substitution to solve real-life modules. So let's jump in. If the marginal revenue for ski gloves is the M marginal revenue bar, which is equal to negative 27 all over the square of 3x plus 10, everything added to 50, and where the revenue at 0 is 0, find the revenue function. All right, so we're given pretty much the derivative of the revenue, so we can kind of maybe write it here saying, oh, this is technically the derivative of the revenue. That's how we translate that. And our goal, the goal is to find what is the original function, right? What is the original revenue? All right, so, and we're given that r of 0 is 0, which we'll use in some time. All right, so we're ready to jump in. All right, so what we need to do is to find the original function, but the problem here is that we're only given the derivative, which is good enough. All we gotta do is find a way to undo the derivative. So this is where the antiderivative will jump in, right? We can find the antiderivative on both sides of the equation, then we can undo that derivative. So that's what we're going to do. So let's go ahead and do that. Take the antiderivative on the left, take the antiderivative on the right. Whatever we do on the left side, do it to the right side. This is going to give us r of x because those will cancel each other out, right? So we're left with the antiderivative of this. Now, for this moment, I'm going to go ahead and move this to the numerator, right? That will help us save some steps here. And then plus 50 dx, right? All right, so we're finding the antiderivative of this. If you notice, this part of the problem, we're not gonna be able to use this term. We're not gonna be able to use a basic rule of the antiderivative. We can for this one, but not for this one. In fact, we actually have to use the U-substitution for this term. So what I would recommend here is to separate these two parts, right? So let's separate these two terms. We hardly do that, but I think for this problem it will be beneficial if we separate it into each one into their own integral. It's just gonna make everything much easier for us to visualize and stay organized. All right, so let's look at the first integral. In the first integral, we're gonna let u, right? We're gonna let u be this part, right? If you let that be u, that's the inner function. Then u prime, which is u prime should be 3, and that's just a factor of constant, which is not a big deal, right? We can actually always come up with a number. So it seems like this is gonna work out just fine if we let the inner function 3x plus 10 be u. So du will be 3 times dx. And so when we go back and replace that in here, we're going to have negative 27 times u to the negative 2. And then we have to multiply this by dx. So what we're going to do here is, well, we have this extra 3 that we can just divide both sides by 3, which will isolate the dx. So we'll have du over 3 equals dx. So we're going to do that to replace the dx, which will be du over 3. For the next term, we don't actually need to do that. That one we can just use a basic rule of a constant, right? So anyways, all right, so everything is ready almost, right? We need to remove this 3, or we can just say, oh, well, this 3 and this negative 27 can simplify to be negative 9, right? So let me rewrite this again. The antiderivative negative 9 u to negative 2 du plus the antiderivative of 50 dx. And if you notice, you gotta be careful though, because the first integral is in terms of u, right? The second integral is in terms of x, but that should not be a problem. We should work with them independently of each other, right? That's why we separate them in this line. That way we don't mess we don't need to use u here, so there's no reason for us to complicate that part of the process. So because it was a simple enough to take the antiderivative, we didn't want to complicate it using u, right? That's why it's separated. All right, anyways, now let's go ahead and jump in and take the antiderivative of this. So for the first one, we can take the antiderivative of that by using the constant multiple rule and the power rule. So -9, and then u to the -2 plus 1 all over the new power. And then the plus c, but we're going to hold on the plus c, plus 50x plus c, right? And then u is a function of x, so we shouldn't be a problem for us to rewrite that. So it'll be -9 over -1 u. We can write u in terms of x by using this here. 3x plus 10 to -1 plus 50x plus c, right? So we only have to add one c for the entire expression. And then, so now we can move this. We can say, oh, well, this -1 and this negative will cancel each other out. And then we can move this power to the denominator. So we're going to have 9 all over 3x plus 10 to the 1 power. And this will give us plus 50x plus c. All right, so good. So this is our r of x. All right, and so we have found r of x, but this is not specific enough, right? We need to actually find the entire function, and since we're given something specific about the revenue function, we can use that to find what is the actual value of c. So let's go ahead and do that. Let's use another page here. That's not good. All right, so let's go ahead and use r of 0. So r of 0 is going to be 9 over 30 plus 10 plus 50 times 0 plus c, and this is, according to this, equals to 0. So in this part of the process, in this part, we're gonna say, well, this is gonna be 0. 9 over 10 is 9 over 10, plus 50 times 0, which is 0, plus c equals 0. If we subtract 9 over 10 on both sides of the equation, these will cancel each other out, and this will give us that c is equal to -9 over 10. So that means that r of x is equal to 9 over 3x plus 10 plus 50x minus 9 over 10, which gives us the actual function, right? And that's it, right? So we found our c, we found the original function, and that's all they ask us to find, right? So anyways, let me know if you have any questions. Thank you so much. See you next time. Bye bye.